Very good evening, students. In today's class, we are going to study what are the characteristics of an op-amp for an ideal case and also the parameters which is related to the operational amplifier. So the following are the listed characteristics of an operational amplifier. So the first characteristics is it has infinite voltage gain. That is, the gain of the amplifier will be very high, and for an ideal op amp it will be infinite. That is what it is given here. The voltage gain, which is also known as differential gain, differential open loop gain, and is infinite in an ideal op amp. Second characteristics is infinite input impedance. Infinite input impedance, it is represented by R in, and as I told you in the introduction part, the input impedance of an op amp will be very high. So for an ideal op amp it is infinite. So this means that no current can flow inside an ideal op amp. So third characteristics, it is zero output impedance. So the output impedance of an op amp, it is represented by R0, and for an ideal op amp it is 0. It means that the output voltage remains the same irrespective of the change in the load connected to the op amp. So fourth characteristics, it is zero offset voltage. So offset voltage, it is represented by VIOS. So what is this offset voltage? See, whenever an input voltage is not given for an op amp, that is both V1 and V2 is equal to 0, we normally expect that output voltage will be 0. Whereas for an ideal case, this output voltage will be 0. So we'll name it this output voltage as offset voltage. That is what for an ideal op amp, offset voltage will be 0. Whereas for a practical op amp, there will be some offset voltage across the output terminal. And next characteristics is infinite bandwidth. So bandwidth of an op amp will be infinite. That is, the range of frequencies over which the amplifier performance is satisfactory, we'll call it as bandwidth, and normally the bandwidth of an op amp will be infinite. Next characteristics, it is infinite CMRR. So what is CMRR? It is nothing but it is the ratio between the differential gain to the common mode gain. So we'll call it as common mode rejection ratio. If it is infinite, it means that the common mode gain is 0 in an ideal op amp. Next characteristics, it is infinite slew rate. So what is slew rate? It is nothing but the maximum rate of change of the output voltage with respect to the time. So in an ideal op amp, slew rate will be infinite. So this means that the changes in the output voltage occurs simultaneously with changes in the input voltage. So every change in the input voltage, it affects the output voltage. And this is represented by a parameter called slew rate S, and it will be infinite for an ideal op amp. So the next characteristics is effect of temperature. That is, there is no effect of temperature. So what it means is, for an ideal op amp, the characteristics of an op amp does not change with changes in temperature. That is, the characteristics will remain the same if we change the temperature where we are operating the op amp. And the last characteristics is zero PSRR. So what is PSRR? It is power supply rejection ratio. It is defined as ratio of change in the input offset voltage due to the change in the supply voltage, keeping the other supply voltages as constant. That is, we are going to find what is the changes in the input offset voltage because of changes in the supply voltages, that is VCC and VEE, by keeping the other voltage we are as constant. So in an ideal op amp, if you see the PSRR value, it will be 0. So these are the various characteristics of an ideal op amp. So we need to keep it in mind the various characteristics of an op amp as infinite voltage gain, infinite input impedance, zero output impedance, zero offset voltage, infinite bandwidth, infinite CMRR, infinite slew rate, and it does not depend on the temperature, and zero PSRR. So these characteristics are very important in analyzing the operation of an operational amplifier. So let us learn what are the parameters which is related to operational amplifier. So the various parameters are common mode rejection ratio, maximum output voltage swing, input offset voltage, slew rate, input offset voltage drift, input bias current, and power supply rejection ratio. So these are the various parameters which is related to the op-amp. So let us define what is the parameters. So the first parameter, as we have seen already in the characteristics of an op-amp, it is nothing but the ability of an op-amp to reject the common mode signal. That is, it is ratio of the differential gain to the common mode gain, and it is very infinite in the case of an ideal op-amp, and it is represented as 20 log of AD divided by AC, whereas AD is the differential gain and AC is the common mode gain. Second parameter is maximum output voltage swing. What is the output voltage swing? See, when there is no input signal, the output of the op-amp ideally will expect that it will be 0 volt. When an input signal is applied, the ideal limits to a peak-to-peak output voltage of plus VCC, and also it depends on the load resistance. So the maximum output voltage what will be obtaining when there is no input voltage applied, will call it as maximum output voltage swing, and also it depends on the load what it is connected across the output terminal. So the third parameter is input offset voltage. So what is the input offset voltage? See, it is represented by VOS, and it is the differential DC voltage required between the inputs in order to force the output voltage to 0 volt. See, what it means is when there is no input, normally we'll expect the output to be 0. So if there is some output, what we need to do is we have to nullify that output. So for that, a small input voltage we are going to apply across the input terminals to make the output as 0. So this voltage, we'll name it as input offset voltage. Normally it will be in the range of 2 millivolt or less than that. So the next parameter is slew rate. Slew rate is defined as the maximum rate of change of the output voltage in response to a step input voltage. That is, whenever we are providing an input of unit step signal for an operational amplifier, we'll find what is the maximum rate of change of the output voltage with respect to this input, and this will name it as slew rate. So the fifth parameter is input offset voltage drift. So it is represented as a parameter, and it is related to VOS, that specifies how much change occurs in VOS for each degree changes in temperature. That is, if there is any change in increase or decrease in temperature, so what is the changes in the VOS. So it is defined by input offset voltage drift. So the next parameter is input bias current. So input bias current is the DC current required by the inputs of the amplifier in order to operate the first stage of an operational amplifier. That is, in the first stage we might have seen there is an amplifier. I'll show you the block architectural. So we have a differential amplifier as a first stage here. So in order to drive the differential amplifier, so we need to give some minimum input voltage across V1 and V2. So that is what we have defined here. So it is the input bias current which is required by the inputs of the amplifier in order to operate the first stage. It is nothing but average of both the input currents. So it is represented as I bias, which is equal to I1 plus I2 whole divided by 2. So the last parameter is power supply rejection ratio. So this parameter, so the next parameter is power supply rejection ratio, and it is defined as change in the input offset voltage due to the changes in the supply voltages, that is VCC and VEE, producing it, keeping the other supply voltages as constant. So we can define PSRR is equal to the VIO, that is changes in the input offset voltage VIO to the supply voltage VCC by keeping other supply voltages as constant. So these are the various parameters which is related to the operational amplifier. So once again I will list out. It is CMRR, maximum output voltage swing, input offset voltage, slew rate, input offset voltage drift, input bias current, and the power supply rejection ratio. So thank you students. Let us continue in the next video. Thank you.